Hello there, science enthusiasts. Welcome to our channel where we delve into the riveting mysteries of the universe. Today we embark on a journey that takes us to the very edge of human imagination and scientific speculation. Imagine, if you will, a future where the human race has advanced to a point where we can harness the full energy of our sun. A future where we have constructed a megastructure so vast it encompasses the sun entirely, capturing every photon of sunlight and converting it into usable energy. This, my friends, is the concept of a Dyson Sphere. Named after the legendary physicist and mathematician Freeman Dyson, the Dyson Sphere is not just a testament to human ingenuity, but also a beacon of our ever-growing need for energy. Picture a shell or a series of rings completely enclosing the sun, soaking up every bit of its energy output. We're talking about an energy source that's nearly 400 trillion times what the world currently consumes. Mind-boggling, isn't it? Yet as grand as this idea may seem, it comes with an equally grand question. A question that has sparked countless debates among scientists, philosophers, and dreamers alike. Should we, the denizens of Earth, destroy an entire planet, Mercury to be precise, to create this celestial powerhouse, the Dyson Sphere? Before you recoil in horror or jump in agreement, let's consider the magnitude of this proposition. We're talking about dismantling an entire planet piece by piece, atom by atom, and using these materials to build a structure of unimaginable scale. It's a concept that's as awe-inspiring as it is terrifying. Now, you might be wondering, why Mercury? Why not any other planet or perhaps an asteroid? Why should poor Mercury be the one to face the cosmic guillotine? Well, my dear friends, there are reasons aplenty, but to truly understand them, we must delve deeper into this great debate. So let's delve into that, shall we? So, why Mercury? Why not any other planet or celestial body? You might be wondering. Well, the choice isn't as arbitrary as it might appear. Mercury, our solar system's smallest and innermost planet, holds a few key advantages that set it apart from its planetary siblings. Firstly, let's look at its location. Mercury is the closest planet to the sun, which makes it an ideal candidate for solar energy harvesting. The closer we are to the sun, the more sunlight we can capture, and the more energy we can generate. It's like standing next to a bonfire. You feel the heat more intensely when you're up close, right? The same principle applies here. Now, let's talk resources. Mercury is rich in elements like silicon and iron, essential raw materials for constructing a Dyson Sphere. If we're going to build something of this magnitude, we need a substantial amount of resources, and Mercury packs quite a punch in this regard. It's like a cosmic treasure trove, ready to fuel our ambitious project. And finally, there's the matter of gravity. Mercury's gravitational pull is relatively low, about 1/3 of Earth's. This means it would be easier to break apart and use its material for our Dyson Sphere. Imagine trying to lift a heavy object on Earth compared to lifting the same object on the Moon. It's significantly easier on the Moon because of the lower gravity. Similarly, deconstructing Mercury would be less energy intensive than attempting the same feat on a larger planet with a stronger gravitational pull. So Mercury's proximity to the Sun, resource abundance, and low gravity make it the prime candidate for our hypothetical project. It's like the Goldilocks of planets for this endeavor. Not too big, not too small, just right. But is it even possible to destroy a planet? Hold on to your seats, because this is where it gets interesting. Destroying a planet sounds like something straight out of a science fiction novel, doesn't it? But let's delve into the realm of theoretical feasibility. Imagine, if you will, the sheer magnitude of energy required to completely obliterate a planet. We're not talking about a small asteroid here, but a celestial body of Mercury's stature. It's a bit like trying to vaporize the Great Wall of China with a laser pointer. What kind of technology would we need to pull off such a Herculean task? To put it into perspective, the total energy needed to destroy Mercury would be about 100 billion megajoules. That's a 1 followed by 20 zeros. To give you an idea, that's roughly equivalent to the sun's entire energy output for a week. We currently don't possess any technology capable of harnessing such immense energy. Even our most powerful nuclear weapons wouldn't make a dent. We'd need a new kind of technology, something far beyond our current scientific understanding. But let's say, hypothetically, we've cracked the code, we've invented the technology, and we're ready to start blasting. There's still the question of what happens next. The resulting debris from Mercury's destruction would be scattered across our solar system, posing a significant threat to other planets, including our own. Not to mention, tampering with the delicate balance of our solar system could have unforeseen and potentially catastrophic consequences. And then there's the moral and ethical question. Even if we could, should we? Is it right to destroy a celestial body that's been a part of our solar system for billions of years, all for the sake of human advancement? With the current technology at hand, it seems like a far-fetched idea, but what if we could? Imagine a future where we have the power to destroy and create celestial bodies at will. In this future, we could harness the energy of entire stars, reshape the cosmos, and elevate our civilization to a level we can barely comprehend today. The potential benefits of such power are truly staggering. With a Dyson Sphere around the sun, we could capture and use every photon of energy it emits. No more energy shortages, no more power cuts. We could power every city, every home, every device on Earth and beyond indefinitely. But let's not forget, power of this magnitude comes with its own set of challenges. The sheer scale of the project is mind-boggling. It's not just about the technical hurdles, but also the socio-economic implications. How would we distribute this near infinite energy? Who would control it? Could we ensure it's used for the benefit of all, or would it become a tool for the powerful few? And then we have the ethical considerations. Do we have the right to destroy a planet, even one as seemingly lifeless as Mercury? Would we be playing God, meddling with the natural order of the universe? And what if we're wrong about Mercury? What if, against all odds, it harbors life in some form we've yet to discover? There's no doubt that the power to create a Dyson Sphere could revolutionize our civilization. It could be the solution to many of our problems, from energy shortages to climate change. But it's not a decision to be taken lightly. It's a decision that would shape the future of our species and perhaps the future of life itself in the universe. And let's not forget, we're talking about a project on a scale we've never attempted before. It would require a level of cooperation and coordination unlike anything we've seen. It could bring us together as a species, or it could tear us apart. It's a tantalizing prospect, isn't it? But it's not just about the technical feasibility, there's more to it. So should we destroy Mercury to build a Dyson Sphere? It's not a simple yes or no answer. We've ventured through the realms of science and ethics, unearthing the considerable weight of this question. Let's revisit the key points of our journey. First, we contemplated the magnitude of the debate. The decision to dismantle a planet, even one as seemingly unimportant as Mercury, isn't to be taken lightly. It's a decision that requires a thorough understanding of the potential impacts, not just on our immediate future, but on the long-term trajectory of our species. Next, we delved into why Mercury? Why not another celestial body? We found that Mercury's proximity to the Sun and its rich iron core make it a prime candidate for a Dyson Sphere's construction. Yet the question remains, does its potential outweigh the risks and ethical concerns? Then we broached the subject of planet destruction, a concept that sounds like it's straight out of a science fiction novel. We discovered that while our current technological capabilities fall short of such an ambitious endeavor, the future may hold different cards. We also discussed the implications. The potential for unprecedented energy capture is tantalizing, but the ripple effects of such an action could be far-reaching. Would we be opening Pandora's box, setting off a chain of events we can't predict or control? So here we stand at the crossroads of ambition and caution. The prospect of a Dyson Sphere brings with it the promise of energy abundance, but at what cost? This is a debate that will continue to evolve as our technology and understanding of the universe expands. And we want to hear from you. What do you think? Should we venture into such ambitious projects, or should we tread carefully? If you enjoyed this thought-provoking journey, do hit the like button and subscribe for more such insightful content. And don't forget to join the conversation in the comments below. Until next time, keep exploring.